Hello, sir. Good afternoon.
Hello, good afternoon.
We welcome you, sir, on the behalf of JL Bajaj family. We are honored
Thank
to
you.
have you as a session chair.
Thank you so much. Yeah, most welcome.
Uh,
So
this
I
side,
think so.
Dr.
Yeah, we should wait for a few more minutes because I think so. Still, we have
Uh,
some time, correct?
yes, 10 minutes, 12 minutes are left to begin the
Okay,
session.
okay.
And we were also calling the authors to join as soon as possible.
Sure, sure, sure. Okay, I'll be waiting here.
Yeah.
No problem. Yeah,
Yeah. Thank you, sir.
most welcome.
Good afternoon, sir. Am I audible?
Hello, good
Welcome,
afternoon.
ma'am. Yes, you are audible.
Can I share my screen?
Just wait for 2, 3 minutes. One more session chair is going to join. Just wait for 2 minutes.
Okay, sure.
Hello.
Could you? Hello, ma'am. Dr. Neeta Kumari.
Yes,
Yeah, we would like to welcome you on the behalf of GL Bajaj family. We are honored to have you as our session chair. Thank you for joining, ma'am. With your permission, can we start?
yes, sir.
Now,
Dr. Harimohan Rai, sir, can we start, sir?
Yeah, of course. Yeah, we can start.
Yeah. Ms. Devyani, please present your PPT.
Yes, sir. Give me 5 minutes. Give me 2 minutes, sir. I'll share my screen with you.
Yeah.
yeah, ma'am.
Sir, is my screen visible? Sir, am I audible?
Yeah, your voice is fluctuating. Can you make it sure that your audio device is fully connected, please?
Okay, sir. Sir, is my screen visible?
No.
No, ma'am.
Okay.
Ma'am, click on the share button and share whole screen.
Either one time.
I have to give permission again and again.
Okay, ma'am. Try. Just wait. Can I move to the next author, Jatin Sharma? You're audible. Jatin Sharma, are you here?
Yes, sir. Yes, sir.
Okay.
Good afternoon, sir.
Now, very good afternoon. Can you share your PPT? Are you ready?
Yes, sir.
Okay. Divyani
Please
ma'am,
give me access.
Yes,
Divyani
sir.
ma'am,
You leave the meeting and rejoin it. Maybe in that way you can resolve your issues. Meanwhile, we are giving chance to our next author to present
Okay,
his
sir.
paper.
Okay, sir.
Okay.
Okay.
Yeah, Jatin sir, now you can share your PPT.
Sure, sir, sure.
Yeah.
Good afternoon, sir. My name is Jatin Sharma. I am from Chitkara University. My paper ID is 291, and my topic is Advanced Animal Image Classification using the Exception Model, achieving high accuracy in diverse species recognition. So this is my table of contents. Coming up with the introduction, first importance of animal image classification. The classification of animal image is crucial for various reasons, including promoting biodiversity conservation, facilitating ecological students studies, and providing better user experience in apps and tools. Technological advancements in image recognition. Deep learning algorithm, particularly neural networks, have revolutionized the way computer analyze and interrupt images. The advancements in image recognition and deep learning includes convolution neural networks, allow for accurate classification of animal species based on visual input, paving the way for application in wildlife monitoring and biodiversity research. Role of the exception model. The exception model developed by Francois Cholet excels in animal image classification due to its use of depth-wise separable con- convolutions, which significantly reduce computationally cost while improving performance. Potential application and use cases. By leveraging the power of the exception model for animal classification, this approach enables the categorization of 15 diverse animal species with high accuracy. So, coming up with the problem statement, the classification of animal species from image poses significant challenge due to these subtle visual difference between the similar species. Traditional methods struggle with accuracy and scalability, especially when processing large dataset in wildlife monitoring and biodiversity research. This research aims to leverage the exception model to classify 15 distinct animal species with high accuracy and offering a scalable and efficient solution for biodiversity conservation, wildlife monitoring, and ecological studies. So my objective is develop an automated animal image classification system to design and implement an efficient system using the exception model for the automated classification of the 15 diverse animal species from image. Optimize model performance to fine tune the exception model for enhanced accuracy in animal classification by leveraging its depth wise separable convolution architecture, improving feature extraction and reducing computational costs. Evaluating classification accuracy and efficiency to assess this model's ability to accurately classify animal species, comparing its performance to traditional method in terms of precision, recall, and computable efficiency, facilitate biodiversity and wildlife monitoring. To demonstrate how this automated classification system can support biodiversity research and wildlife conservation efforts by processing large dataset with minimal human intervention. So this is the methodology. The proposed methodology follows a structured approach divided into four phases. In the data preparation phase, the data set from Kaggle is processed by standardizing pixel value and applying augmentation techniques like rotation and scaling to enhance diversity. The data is split into training, validation, and testing sets. In the model development phase, the exception model is configured using depth-wise separable convolutions. The training and validation phase involves using optimization techniques and continuously monitoring the model's performance to ensure generalization and prevent overfitting. The analysis phase involves evaluating the model's performance using metrics such as F1 score, recall, and accuracy. These metrics provides a detailed understanding of the model ability to classify animal species accurately. The testing set is used to measure how well the model generalized to new data. The results highlight area of strength and potential improvement, guiding future adjustment to enhance the model's overall performance, reliability, and its ability to handle a wide variety of animal species. Results: classification report analysis, high accuracy. The exception model achieves on overall accuracy of 96% on the 2407 photo test set, demonstrating its strong capability in classifying image across 15 animals category. Excellent precision. The model show exceptionally precision with beetle 0.97 and cat 0.98, indicating its ability to correctly identify the species with minimal false positives. Strong recall scores for categories like butterfly 0.96 and cat 0.93 reflect the model's eff- effectiveness in detecting relevant animal species, minimizing false negatives. Reliable F1 scores. The model's consistent F1 scores, such as 0.95 for beetle and 0.96 for cat, demonstrate a balanced trade-off between precision and recall, ensuring reliable and accurate classification across various animal species. And this is my conclusion. The exception model demonstrated exceptionally performance in classifying image of 15 different animal species, achieving an impressively overall accuracy of 96%. It its innovative design features depth-wise separable con- convolution significantly enhance both computationally efficiency and classification accuracy, making it highly effective in distinguished closely related species. The model ability to achieve high presence and recall, especially for classes like beetle and cat, showcase its capability to efficiently handle challenging classification tasks. The confusion metrics further validate the model performance and pinpointed area of for potential improvement. Training and validation losses remain low throughout, indicating efficient learning and the model's ability to generalize well on new data. The strong accuracy across both training and validation sets reinforces its real-world applicability. The exception model's strong performance opens up opportunity for its application in interactive learning tools, wildlife research, and biodiversity monitoring. Further research can focus on enhancing the model's performance on more diverse dataset, fine-tune it for real-time application, and expanding its usage for broader ecological and environmental studies. So these are the references I used. Thank you. Now I am open for question and answers.
Hello, Jatin, can you hear me?
Yes, sir.
Can you share me the slide again, please? Because I think so you have, I mean, you have the slide which you are presenting. Can you share it again, please?
Yes, sir. Yes, sir. 1 second, sir.
Yeah. So, Jatin, are you a student right now? You're studying somewhere?
So yes, I'm a student.
Which year you are?
Uh, uh, sir, in second year.
I
I'm tech
mean,
second.
BTech batch,
I'm tech
MTech
sales.
second year.
Yes, sir.
Okay, so this work has been done by you or some like your colleagues or your guide or something, someone else?
So it's done by me and
I
guide,
don't think
with
so.
the help of guide, basically.
You know why? Because many of the terminology you are not aware of. Why I'm saying, you see, maybe it is required for your master degree because it's compulsory nowadays. Okay, without that,
Yes.
your thesis will not be completed. But what I found that most of the terminology or most of the terms which has been used in this paper, you are not aware of basically, like you are not familiar if, okay. So I suggest because you are a student and you have huge career learning, in learning stage. So I suggest you to please at least go through the papers which are going to present it. If you are finding some difficulties, you ask your guide or your teachers or someone who understand it, okay. Because you see, you are, I think so, maybe in computer science department, and
Yes, sir.
nowadays like machine learning models, they're working, how it works, what are the models used, what are the features, and what is the pre-processing techniques. These are the very common nowadays, okay. So what I suggest as per my knowledge, that because this is the learning stage, you all are just wanted to learn, and you are presenting this paper because in this one will make you to learn something. For example, this problem statement which you have mentioned, it is just a paragraph, but it should not be in the paragraph. Problem statement is your, like, it should be in a point wise, bullet form, like 1 or 2 points or 3 points what you wanted to basically resolve, what are the issues you are going to resolve it out, correct? That's called
Yes.
problem statement. Have you drawn any image like methodology? Can you show me again? Proposed methodology, anything which you have, block diagrams, anything?
So in paper, it's there.
Because block diagram is the main part of your papers, because that explains how what you are going to do, from first to last. So this is only my, I mean, suggestion, not questions, because I know you are students and still you wanted to improve yourself. So my suggestion is to, I mean, whenever you do some papers with your guide or with your partners, try to read it out once, try to understand the terminology, and try to understand about the paper, what result it says and how you got the results. So that's it. Best of luck from my side. Thank you.
Sure, sir. Thank you, sir.
Welcome. Yeah, can we call for the next author, please?
Yeah, thank you, sir. And the next paper ID is 43, Divyani Rawat. You join again.
Yes, sir. Yes, I have joined it again.
Yeah, let me make a presenter. Yeah, now you can share your PPT.
So is it visible now?
Yes, ma'am, it is visible. Just click on PowerPoint presentation, PPT. Yeah.
Okay, very good afternoon to everyone. Here is Devyani Rawat from Graphic University. My paper is about the title of my paper is Machine Vision Technique with Image Segmentation in Digital Diagnostic System for Lung Cancer Detection. Basically, it's a review paper. I have just reviewed the work of some authors. After that, I'm going to implement the same technique. So here are my table of contents. Following points I'm going to discuss in my presentation. It
Ma'am, sorry to
includes.
interrupt you in between. I think so. Uh, can you hear me?
Yes, sir. Sure, sir.
I think so your slideshow is not working. I mean, not moving basically. Maybe because of your internet is very slow. Maybe that reason, poor network connectivity. So
Sir, are you able to see my table of contents?
yeah,
Uh,
I'm not able to see it because it's okay. Can you move it? Can you go to the next slide, please?
Introduction and
Yeah,
brief
it's okay.
review.
It's okay. 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 Yeah. Oh, go ahead. Go ahead. Yeah.
Okay, sir. Okay, sir. So, okay. Okay, so following points I'm going to discuss in my presentation. So let's start with the introduction and brief review. Basically, we all know that lung cancer remains a critical issue worldwide. So it requires a progressed imaging advances for early detection. This paper basically presents an advanced symptomatic framework enabled by machine vision, especially centering on image segmentation techniques. Through a comprehensive survey of existing writing, we have investigated the scene of image segmentation procedures connected to lung cancer locations. And we have also examined that potential suggestions of this approach in clinical settings, including its capacity to help radiologists in elucidations and decision making. And besides, we highlight the avenues for future investigate and advancement to define and optimize the proposed framework. This is the proposed methodology which we are going to follow in the implementation part. So basically the proposed methodology for machine vision with image segmentation, it begins with the acquisition of high quality medical images of medical images of lungs, which includes X-ray, CT scans, and MRI images from reliable resources. Following this, the acquired images undergo pre-processing to enhance quality, remove noise, and standardize image characteristics, employing techniques such as denoising and normalization. And through this comprehensive technique, successful computerized demonstrative frameworks for the lung cancer detection can be created, leveraging the machine vision procedures to improve persistent care and results. These are the techniques and applications of machine vision. First of all, is image processing, pre-processing, segmentation, feature extraction, classification, deep learning, data fusion, decision support system, validation and evaluation. Sir, if you want, then I can explain each of these techniques.
No, ma'am. Just go ahead because already these are the very common techniques
Yes,
nowadays.
sir.
Yeah.
And these are the advantages of machine vision. Basically, it provides the early detection. Objective analysis can be done. It also increase the efficiency of the model. It also helps in reducing the cost and integration with decision support system. We can integrate with this technique with other systems also. These are the challenges which we could face while working with this technique. First of all, issue with data quality and quantity, complexity of lung anatomy, regulatory and ethical consideration, and generalization of to diverse populations. This is the comparative analysis, and we have done using different approaches. अरे यार चावल फूक गए कहाँ गए? Am I audible, sir?
Yeah, you're audible.
Yes, ma'am. Yes, ma'am.
So we have basically compared other techniques given by other authors. Some has used CNN with SVM and they have got 97.91% accuracy. And using with dense neural network, they have got 99.07% accuracy. Basically, they all have worked on images of lung cancer and they have got this much accuracy. And when we are going to implement this present technique, we are going to use machine vision with image segmentation for digital diagnostic system. These are the future scope which could be done in futuristic, like upgraded precision productivity, combination with multimodal information, clinical choice, emotionally supportive network, and ongoing analysis and intercession. This is the conclusion of my presentation. In advanced symptomatic frameworks for cellular breakdown in the lungs location, basically machine vision methods and picture division work synergetically to upgrade the exactness of productivity and the speed of conclusion. Basically, this work will enhance the previous work. This will basically enhance the previous work which already done on lung cancer detection. These are the references which I have used in my presentation. That's it. Thank you, sir. Now you can ask me any questions.
Hello, ma'am. I think okay, as per review papers, you have done good work. But I want to ask something, related to your proposed methodology. Can you show me it? Show me again, please.
Sure, sir. Yes, sir.
Yeah, ma'am, this is the proposed methodology, but I suggest you that this is very generalized. Top. I mean,
Actually,
steps. Yeah.
yes, sir. Yes, sir. Yes, sir. Continue, sir.
Yeah, because like see, because you have reviewed the paper or you're going to review the papers. So, for example, you have reviewed 10 papers or 20 papers or maybe 30 papers, and after that, the whatever you conclude, based on that, you propose your methodology. Like what you're going to do. So, as per my suggestions, like when you review the present review papers, you just what proposed methodology you are going to apply. For example, in image processing, image pre-processing, you can apply, for example, RGB to gray techniques, or even like there are many pre-processing techniques, normalization techniques or standardization techniques. Okay. Similarly, like you have a feature extraction, so there are a variety of feature extraction techniques you have. So you can, because this is the proposal, this is not final one. So proposal you can give like generalized general topic, not the sorry, a specific topic, not the generalized one, is my suggestion one. So if you have to say something about it, so you can say, no problem.
Sure, sir. I'll definitely take your suggestion. What I'll
Mhm.
do, I'll just enhance this proposed methodology using with the particular technology which I'm going to use in implementation
Yeah,
work.
yeah, that
Uh,
will be good. And another suggestion will be like, whenever
O
you are
seat light
writing
up
the
in
review.
way.
Hello. So if you
Okay.
are
yes,
doing, yeah, yeah, if you're doing the
Abhiya.
hello, Dina, please mute yourself. Okay, so and one suggestion is that whenever you're writing review papers, no, so at
yes,
least you just make a table with at least 10, 15, 10, whatever the number of papers, and you just show that how much what you have done in that one, like like how much accuracy you have got, what are the positive aspects of that paper, so what is the negative aspect of that paper. So that gives you the better analysis, or even someone going to read it out, it will be a good it will become a good paper. So this is my suggestions only, so please look it
thank
into
you so
this
much,
this
sir.
this
Thank
one.
you so much, sir, for your suggestion. I'll definitely incorporate them in future.
Okay, welcome.
Okay, thank you so much, sir.
Most welcome.
Okay, thank you, ma'am. Next paper presentation ID is 409. Dina.
Yes, sir. Very good afternoon. Am I audible?
Good afternoon. Yeah, you are
Yeah,
audible.
sir.
Let me make a presenter.
Yes, sir.
Good afternoon, sir. Good afternoon, sir. Good afternoon, sir. Good afternoon,
एक को म्यूट कर
Sir, is my screen visible?
Yes, it is visible.
Yes, sir. So shall I start?
Then are you presenting through your mobile phone?
Yes, sir. I've put the slide in my mobile phone. Is that okay?
Okay, is it okay, but you are not available? Yeah, I mean your system or laptop is not available with you.
Yes, sir.
Okay, are you in class or somewhere? Because there's a noise around you. And if
So
possible,
voice,
if
actually voice is not from my side because I'm in a closed environment, sir.
okay, so is it not possible to use a laptop because the screen is very, we are unable to
Very
look it
short.
out. If
Okay,
yeah,
okay,
so
just a
if
minute.
possible, you can take yeah, if you take it 2 minutes time, because we are not able to see exactly what you are in the
Okay,
screen.
okay, okay, just a
Hmm.
minute. Just hold on, sir. I'll just connect it. Just a minute. Mm.
afternoon, sir. My paper ID 284. Sir,
Ruchika,
yes, sir. It's request from my
284.
side. Actually, my baby is crying. So may I represent?
You can.
I think so. Yes,
Just
sir.
1 minute.
She
Wait.
can go ahead. Yeah, I can wait. I'll make the
Okay.
connection. Yes,
Okay.
yes.
Thank you,
Thank you.
Dina. So,
Thank you.
yeah,
Thank you so
Rishika
much.
can present now. Welcome.
Okay.
Yeah, so you can go
Yeah,
ahead, please.
Ruchika, now
Please give me share
you can
option.
present your PPT.
So the share option is not enabled.
Yeah, just a second. Yeah, now you can share. Please check.
Yes, sir. It's enabled. My screen is visible.
Yeah,
So
Yes.
my
it's
screen
visible.
is visible.
Mhm.
Yes, sir.
Go ahead.
Thank you,
And
sir.
Ruchika,
Actually,
one thing, please sum up within a 5 to 6, 7 minute because
okay,
we
sir.
will extra.
Actually, I
Yeah,
have also problem. My baby's crying. So, good afternoon, sir.
yeah, please take it.
My name is Ruchika Bhuria. I am from Chitkara Institute of Engineering and Technology. I'm going to give a presentation on my research work, and the title of the research work is Leveraging XGBoost for the Accurate Brain Stroke Prediction, an Innovative Approach to Data-Driven Healthcare Solution. These are the roadmap that I performed in my research work: introduction, key contribution, input data set, results, and conclusion. Introduction. Stroke is the second leading cause of the death globally, responsible around 11% of the total deaths, according to WHO. It's a major contributor in long-term disability. Early detection of stroke risk is critical to enable timely intervention, reduce healthcare costs, and improve patient outcomes. The research leveraged the XGBoost classifier, a robust machine learning algorithm, to develop a high-performance model for the stroke risk prediction. Efficient pre-processing, including the data cleaning and the feature selection, normalization, hyperparameter tuning, is used. Input data set. Given that the stroke rank is the second leading cause of the death worldwide, the data set not only facilitate the development of the precise machine learning models to estimate the stroke risk, but underscores ethical consideration, encouraging responsible use of the data. This is the CSV file and the sum of the body parameters that I used in this data. Proposed methodology, we divide the data proposed methodology into four sets. In the first phase, that is the data pre-processing, the methodology for the brain stroke classification begins with the robust data pre-processing to ensure the quality and the integrity of the data set. Missing value, particularly in the smoking status attributes, are addressed through the appropriate introduced method. One pre-processing is complete, dataset is split into training and the testing phase, typically 80 into 20 ratios. This ensures the model is trained to large proportion of the data while reserving rest for the validation. Model training. The performance of the XGBoost model is evaluated using a combination of the matrices, including accuracy, precision, recall, and the F1 score, and the ROC AOC. The model evaluation after the validation, the training model is deployed in the real-time environment to provide a stroke risk prediction based on the patient data. The system is designed to assist healthcare professionals by offering timely and the accurate forecast. Result and the discussions. This is the classification reports. The accuracy is 85%. The classification report shows a striking difference in the performance for the model over the two classes. Since the significantly better outcomes for the class 0 and the class 1 with a great accuracy, that is 97, recall 86, and the one score 91%. Slightly better of 56%, that is a recall for the class 1, and the reveals the model misses the almost half, but over half of the real causes. This is a confusion matrix. The confusion matrix emphasizes the model unable performance over the two courses, since 228 instances for the class 1, and the model performed well properly, identifying 1007 out of 1165 instances. Conclusion. The study demonstrated the effectiveness of the XGBoost classifier in the stroke risk based on the range of the patient characteristics such as the age, their medical history, and the lifestyle factor. With the overall accuracy 85%, model has shown the strong performance in the identifying non-strong cases. Future research will several strategies to improve the stroke prediction accuracy. Additional features such as the detailed medical history, genetic data may provide a more comprehensive view and enhance the model accuracy. And SMORT is used for the data imbalance. In the future, oversampling technique also used. These are the references that I use in my research work. Thank you. I'm open for the question answer.
Hello, Ruchika. Can you hear
Yes,
me?
sir.
Yeah,
Yes,
the
sir.
concern is like, see, are you a PhD student or master student? I mean, what you're doing
I am
currently?
a master student. I am a master student, sir.
Okay, because
And this is my
why I'm
initial work. Yes, sir.
okay. So, Yuchika, please, I suggest you ki, like you at least use more diagrams, more tables,
Okay.
more result as
Okay, sir.
compared to text, because you have not presented any block diagrams, you have not put any, result like
Actually, sir,
um.
in research paper, I have used the proposed methodology diagrams, but in PPD, I will not show.
No, no, that is the main thing, because PPT, you should not write. I mean, text, more text. It should be less text and
Okay,
more images. More diagrams. So that should be the
okay, sir.
PowerPoint
Okay,
presentation. Okay, Ruchika. Yeah,
okay.
that's it from
Thank
my
you.
side. All
Thank
the
you.
best.
Thank you.
Okay, any other question from any sessions? I think she is left. Yeah,
So
next
could you
paper ID
please
is
join me
the
in?
Yeah,
Dina.
Yeah, sure. I'm actually waiting. I'm not let allowed in still.
Now please check.
So no, sir.
What
what
happened?
happened?
No, sir. I'm not allowed inside still. So I'm joining it
You
from my laptop in the name of Veena Shivakumar, actually.
Have you joined from both two devices, mobile phone as well as
Yes,
laptop?
yes, yes. Should I
So,
leave from my mobile
do
phone?
can you yeah, can you remove? I mean, just come out from the mobile phone and then you only join with your laptop. Okay, so it will be good.
Okay, okay, okay. So I'm removing from my phone.
sir, another presenter are here. Parul. Okay.
Yeah, Dinesh Kumar says join. Now just give her access.
Yeah.
Now you try.
Yes, sir. Let me share my PPT.
Yeah, ma'am.
Yes. Yes, sir. Is my screen visible?
Yes, yes. Paper
Okay, so
ID
shall I?
409. Yeah.
Yes, sir. Shall I start?
What is your paper ID?
My paper ID is 409.
Okay, okay. Yeah.
Yes, okay. So here,
Yeah, continue. Yeah, continue.
yes, sir. Just a minute. Okay. So very good afternoon. I'm delighted to be here at ICPCT 25 to present our research on using vision transformers with mass guided attention for breast cancer diagnosis. So breast cancer remains as one of the leading cause of mortality in women worldwide.
Early directions plays a very crucial role in improving the survival rates, and ultrasound imaging is very widely used for these purposes. But here, the traditional AI models like CNN still face challenges in interpretability and accuracy. So here, our study is going to leverage vision transformers, that is VITs, and introduce a novel mass-guided attention mechanism to enhance the tumor classification in ultrasound images. So the problem statement here is that the challenge in breast cancer diagnosis using AI lies in model accuracy and the interpretability. As we know, the CNN have been widely used, but often struggle with effectively localizing the tumor regions. And the VITs, as per our study, the VITs have shown very promise in feature extraction, but the current research lacks a lot in mass guided approaches for improved focus on very critical areas. So there is a need for AI models that are both accurate and explainable for the clinical uses. So in order to address this, we propose a vision transformer with a mass guided attention to enhance the tumor localization and the classification specifically. So as goes the objective, so the key objective here is we are focusing on four things, and one, developing a VIT based model that is tailored basically only for breast ultrasound image classification. And number two, incorporating a mass guided attention, which will help us to improve the model's focus on tumor regions. And number three, ensuring high performance in accuracy, precision, recall, and F1 score. And four, enhancing the clinical trust by making AI decisions more interpretable and also reliable. So coming to the methodology and analysis, so let me take you over. To achieve the objective, our study structured methodology. First, the data set. So we used a publicly available BOOSI data set, ensuring the classes that is completely balanced to avoid all the biases. And then we applied mass guided attention. So this is a novel attention mechanism that was directed to the model that focuses only on the tumor regions so that it will improve the classification accuracy. And then we have modified the VIT. So here the vision transformer is modified by using a fine tune of VIT B16 model. So this is a replacing standard attention layer with our custom mass guided attention. Okay. And then we had tumor, and then we do the tumor classification. So tumor classifier is being used. So the model is fully connected layer, and a softmax activation is given for binary classification to basically figure out whether the tumor is malignant or benign. And finally, the training. So the model is being trained. So we employ Adam optimizer and cross entropy loss to figure out the optimizer performance. And through this, we can also reduce the training losses that is coming. So as per, we can see the model architecture. So basically, we are taking the input images and the mask, and then we are reprocessing the images. So we can see we convert all the grayscale images, and then we resize the images, and we also convert the tensor format in it. And then we also then we pre-train it by using vision transformer. That is where VB16 weights have been given, and then mass guided attention. So here in mass guided attention, we do three to enhance the image performance. So we concatenate the image and mask it. We also apply a self attention mechanism, and I also focus on the tumor regions. So after this, CNN, that's fully connected layer. So this layer particularly in one after the results of this will be taken in a fully converted layer. So here the size initially we gathered around 780 breast ultrasound images from the data set, and the age of everybody was from 25 to 75, and average size of the image was 500 to 500 pixel, and everything was in PNG format. And after doing it to the CNN, we can show the areas that highlights only the tumor regions here. Okay, so the resized pixel images was 224 into 224, and once resized, all the images is converted into tensors. After it's converted into tensor, which reformat all the image and mask the data into a structure. So this particular structure will effectively process the deep learning model for us. So as per here, the proposed model, it will incorporate a self-layered mask guided attention. So this will basically improve the classification accuracy for the tumor areas alone. So what happens here is that whenever the mask guided attention is operated by multiplying the attention scores with the mask tensor, it will effectively zero all the attention areas. So whenever there is a tumor inside or whenever there is a region outside the tumor, basically all those areas will be masked to zero. So when it is masked to zero, what happens? The model will be focusing very directly on only the tumor regions. So when we have integrated different images, so there are mask that is going to take up different shapes. So the tensors will first unsqueeze everything into a 4D format. So when it is doing it in the 4D format, so here basically the batch size, the channel, the height, the width, everything is formatted. And then everything will be concatenated using a new tensor. So that is when a mask guided attention process is given by us. So this proves that the entire fully connected layer will tailor the pre-trained model with the help of the mask guided attention layer that is given. Okay. So the output layer will employ it with a softmax function to provide the classification probability. So majorly we have three classification probability that says whether it is benign or malignant or normal. So all these three classes will be set finally. So as we see the result, so we can see the accuracy overall 84% of accuracy was given, localizing the tumor regions. So our proposed model demonstrates that it is a very strong performance in classifying the breast tumors. So here the malignant precision was 83 and recall was 91%. Benign precision was 80, recall was 83, and in normal the precision was 90, whereas the recall was 80. So same F1 scores says the malignant was 87%, benign 81%, normal 85%. So overall, I conclude that the mask guided attention approach significantly improved tumor localization and the interpretability, outperforming the traditional CNN methods. So further, these findings indicates that the VIT with mask guided attention enhanced the breast cancer detection accuracy, and the model outperforms CNN in both interpretability and classification. And our approach has very potential become a valuable AI model for early breast cancer diagnosis in real world clinical settings also. So the future work, so this is a graph. And then coming to the future work, so to further improve on the model, we are planning to expand the data set to ensure the generalizability. And we are also planning to integrate with multi-model imaging like MRI, CT scans for comprehensive diagnosis and optimize the real-time processing here. And we have also planned to implement ensemble learning strategy in order to get even more better accuracy to optimize the image decisions. So that's the references, and thank you. Yes, sir. So this concludes my presentation, and thank you. And I'll be happy to answer any questions. Hello?
Dina, can you hear
Hello?
me? Am I audible?
Yes, sir. Yes, sir.
Okay, sorry. Yeah, it's a good presentation basically, and I appreciate the approach which you have, applied here. Are you
Yes.
a master student or a PhD?
No, sir. I'm actually working as a assistant professor, and I'm also pursuing my
Mhm.
PhD. So I've
Okay,
kept my
okay,
thesis recently now.
okay, okay. So just I would like to ask just basic some questions. You have used
Yeah.
BUSI dataset, correct, for breast cancer detection?
Yes,
BUSI,
sir.
am I correct? So how much
Yes.
data you have used? How much images you have used in that dataset? Can you tell me?
Uh, exactly. Boosi data set had just a minute, sir. It
Can you
had
check in?
almost, yes, sir. Just a minute. It had 780 breast ultrasound images. 780.
But you have not mentioned anywhere in the slide, correct?
Okay, so yes, sir. Yes, sir. In the paper, I have mentioned it. Yes. In the slides, I've not
Yeah,
mentioned
and
it, sir.
okay, and how much data you have taken for training and how much for testing?
So three classes, it is split into 437 images of malignant was there, 210 images I had for benign, and in normal, that is in no tumor, I had 133 images. So basically, I have taken in everything as there is an age limit to everything, I have just taken into 3:1 ratio in everything, sir. Because each image should correspond to the binary mask for me. So I just chose to it 3:1 ratio in every classes separately.
Dina, basically it is like, in machine learning model, when you divide the
Yeah.
training and test split, either it will be like 70/30, 80/20, or like 60/40. This the
Yes, sir.
ratio is
Seventy
like,
thirty only.
yeah,
But
okay.
in every, I should have it for every classes, right? So I took 20 20 20. So I'm just saying the split of each class.
Okay, no, I mean, nah, see,
Yeah.
it shouldn't be like each, individual classes. Automatically, you take the data, complete data, because data set is, it comprises of all three, including your malignant,
Hmm.
normal, as
Ah,
well as
yes, sir.
benign.
Yes, sir. Yes, sir.
Mm,
Of course,
mm,
of course. Eighty
okay,
percentage was
okay.
training set, 20% was testing set.
And third thing is that, because everyone is waiting, so I won't go much, but you have not presented your model here, because just only you have presented block diagrams. So block diagram is nothing but the steps. It includes your step, how you are applying it out. But the
Okay.
model you have explained here, like VIT with, you are using some segmentation, some model. So that has to be,
Okay.
the structure of that, model has, because VIT is very known techniques.
Okay.
It is already
Okay.
has been utilized by every person, many of the person. Okay, but when
Okay.
you're going to combine with some other model, so you just try to draw the structure of the model, whatever you are
Okay.
using. So it will give you,
Okay.
for future purposes, I am telling you, so that it will be give you the
Okay.
better understanding for who is going to read the papers. Okay, thank you.
Okay, sir. Sure, sir. Thank you so much. Thank you for input, sir. I'll
Mm,
incorporate it, sir.
okay.
Thank you. Thank you so much for the opportunity.
Welcome.
Okay, thank you, ma'am. And next presenter is paper ID 340, Mr. Parul. Miss Parul.
Yeah, sir. Miss Pa.
Yeah,
Can I share?
yeah, ma'am. Just a second. Now you can share. Yeah, ma'am.
Is it visible, sir? Is it visible, sir?
Yes, it's visible. Visible. Go ahead.
Okay. Can I start?
Yeah, of course.
Good afternoon. My name is Parul Nasra. I'm here to present my research article named DenseNet based approach for early detection and classification of Alzheimer's disease using MRI images. And my paper ID is 340. Second slide covers the outlines following with introduction, which is then followed by related works, dataset, methodology, results, conclusion, and lastly references. Third slide introduces the paper as Alzheimer's disease is a neurological condition characterized by abnormal behavior, memory loss, and cognitive impairment. It is significant financial and social risk factor for dementia in elderly. Accurate and timely diagnosis is crucial for managing and treating the disease. MRI is easily used in diagnosis. Traditional methods of diagnosis rely on visual inspection of MRI, which can be time consuming and subjective. Deep learning approaches can automate the operation and increase the appropriate rates of fourth slide continues the introduction as predictive diagnosis model and tools grounded on deep learning and machine learning techniques are needed to increase the accuracy and speed of MRI scan based differences in Alzheimer's disease. DenseNet have shown remarkable performance in various medical image processing applications. Deep learning approaches have shown potential for complex biomedical data to identify subtle parts of Alzheimer's disease. The study aims to develop and evaluate a DenseNet based framework using MRI scans for early Alzheimer's disease classification and diagnosis. Fifth slide represents the past work related to Alzheimer's disease. As you can see, the results achieved are accuracy 91, 90, 89, and so on. Um, The sixth slide describes the dataset use. The dataset comprises of 33,984 MRI images, which are divided into 4 distinct classification of MRI diseases, which is mild demented, moderate demented, non-demented, and very mild demented. All classes are represented with high quality T1 weighted MRI images. The presence of training and test subset, which is divided into 80-20, facilitates model building and evaluation. Mild demented has 8960 images. Very mild demented also has the same number of images, whereas moderate demented has 6464 images and non-demented has 9600 images. Seventh slide represents the model used for classification. The model used is DenseNet 201. The model is pre-trained on ImageNet and has multiple connected convolutional layer for efficient feature reusing. The model is downscaled to 244 into 244 pixels, allowing for task-specific layers. The model computes a feature vector, feeds it via a global average pooling layer, and adds a dense layer with 1024 neurons for non-linearity. The final layers include 4 dense layers and probability matching with 4 distinct classes of Alzheimer's disease. The model learning rate is 0.001 and optimizer used is ADAM. Eighth slide represents the graphical analysis of training loss, validation loss, training accuracy, and validation accuracy. The DenseNet model shows the high and reliable with the peak of 92.5 at the second epoch. The model's initial training and validation losses were substantial but gradually reduced to make it more generalized and less overfitting to training set. By the epoch 19, both losses were less than lower levels, with validation loss oscillating around 0.2 and trading loss approaching 0.1. This indicates that the model has been efficiently trained to accurately discriminate several phases of Alzheimer's disease, underlying its potential for MRI imaging-based early detection and tracing of Alzheimer's progression. Slide 9 represents the confusion matrix. The matrix highlights that while the model performed exceptionally well in distinguishing between various classes, there are misclassification, particularly between moderate demented and wild demented, suggesting areas where the model could be further optimized. Slide 10 represents the performance parameters. The model has achieved a precision of 0.92, recall of 0.98, and F1 score of 0.95 for mild demented category, identifying almost 2693 cases correctly. The model's ability to categorize with negligible error margins in the very mild demented category suggests its potential for clinical use in early diagnosis. Slide 10 represents the 11 represents the conclusion of the paper. The conclusion is represented as the paper utilizes MRI data and DenseNet model for Alzheimer's disease classification. The accuracy achieved is 92.5 for different phases. DenseNet architecture provides depth and feature extraction for dense predictions. Model achieved perfect recall, F1 score, and precision. The model differentiate correctly between the healthy and the various phases of Alzheimer's disease. This shows the practical relevance of deep learning applications in neuroimaging diagnosis. The model could assist doctors in prescribing daily treatment if early and correct Alzheimer's diagnosis is allowed. The 12th slide represents the references I used in the paper. Thank you. I'm open to questions.
Yeah, hello.
Yes, sir.
Yeah, Parul, can you go back to your result section, please?
Yeah. Sir, which slide?
Result, can you show me your result? Yeah. Yes, this one. So name of the class, here you have used the black dot, ESCA, healthy, and leap, but you have not, can you show me this, what to say, confusion matrix, please? Confusion matrix.
Confusion matrix.
Yeah.
Yes, sir.
Ninth number slide. Yeah, this one.
Yes,
So
sir.
here
It
this
is
is
open.
this result which you have shown, it is on a training data set or test data set?
This is on test data set, sir.
So how much data you have
No, sir,
utilized
it's
total?
on training. It's on training. It's 80%.
Yeah, that's what I'm saying, because it's a very
Yeah,
huge number, and that should not
yeah,
be, I
yeah.
think so,
It's
in test
on
data.
training.
Okay, and you have not presented your and the result which here you are shown is I think so test data set, correct? The final
This is
result in
training.
the, yeah. And what about this one?
Yeah, this is sir performance parameters. We concluded on test data set.
So that's what I mean. The confusion matrix should be on test data set, because for training you have already shown the result training curve as well as loss curve. Am I correct?
Yeah, sir, it contains both training and validation.
Yeah, I understand that training and validation is already
Only
contained on.
confusion matrix is of training data set. Yeah, sorry, sir.
Okay, no issue. So try to include on test data set, because for this
Yeah, sure.
result should be confusion matrix should be on test data set. Okay. Okay.
Test
Thank you,
data
Parul.
set. Okay.
Okay. That's.
Okay.
Okay, thank you, ma'am. And next paper ID is 351, Dr. Ryan.
Yes, sir.
Yeah, okay.
Good afternoon, sir.
Very good afternoon. Let me make you a presenter. Now you can share your slide. And one thing, please sum up within 6 to 7 minutes.
Okay, sir. Okay, sir.
Yeah. And then QA session.
Sir. Sir, is it visible, sir?
You are using phone. Put it just a slideshow or rotate it. Mode. Is it PPT or PDF?
So the PPT is in PDF, sir. PDF format, sir.
Okay, just move one by one. Yeah.
Good afternoon, sir. Today that I am going to explain about the project title that I am going to convert as a revolutionary cloud security through creation of noise images for file encryption in a cloud-based environment, sir. The first topic that I am going to explain is an abstract. This article explores an innovative approaches to enhance the file encryption in the cloud-based environment by utilizing the noise images for saving file for say sending the images from one place to another place, that we are having some kind of some personal images means, or we are having any kind of security images means, we are having many hackers that we are facing right now. So for that only, that we are using a encryption method to hide the images or hide any kind of files inside the images, that it will be showing like noise images or what kind of images it will be sharing the information. So we can add the files in the images also, we by sharing the information in the cloud based system, that we are adding the informations of any kind of videos or voices or images or any kind of data, that we can be saving the images inside the any kind of image inside any kind of images or any kind of files, to save the information by sending from one place to another place. By encrypting this one, we can the hackers can't be able to find the images, whether it is saving inside the another images or saving inside any kind of folders, any kind of images, any kind of data that is inside. So this is the title that we are going that I make it more efficiently, and in this we are using a cloud based system to hide the images, or we can save the images. For example, if we are using the cloud means, we can have many spaces to save the images or sharing the information. For example, if the images consist of 50 MB or 500 MB means, we can share the information by saving the information in the cloud. So we can share that information through the cloud means, it is very much useful for us to easily open and creativity more than any, sir. In introduction, innovation use of noise images for file encryption represent a groundbreaking approaches in a realm of there is a lots and lots of cryptography projects are already there, sir, for saving the information or saving the information from or sending the information from one place to another place, by hide that information in any of the project or any of the document, to save it to send the information very securely by having the password protections or any kind of fingerprint protections, to sending the informations or any kind of face recognition data also, we can share it with the security. So now the technology was developed. We are make that we can save the information in the cloud to make it more efficient. So the approaches explores a new dimension in cloud security by leveraging the inheritance complexity and the randomness of noise images to enhance the encryption algorithm using cloud-based environment. Mostly we are using the cloud-based environment, so you save the information. For example, if we are sending any kind of images in the mail, means we are having some kind of restriction and some kind of spaces also. We are having 25 MB or 15 MB could share the information. But if we are saving that information in the cloud and sharing one kind of link, means then we can download that images from another place with the help of the network connectivity. The problem statement is nothing but of exploring the innovative approaches to cloud security. The project aims to leave the noise images of the encryption with a cloud-based environment. In the cloud-based environment, we are saving that information by sharing from one place to another placements. They can easily download the files, but they can't be able to open it without any kind of protection, because we already encrypted some kind of images or some kind of files inside the images to show it as a noisy images, or show it as for example, if I am sending one kind of image, one kind of data in some kind of images, means if the hacker hacked the mail ID or hacked the any kind of link, means they can download and only seeing some kind of images. They can't be able to identify what are all the information that is hidden in that image. So in that place that we can easily share the images in a secure manner and with the help of the cloud-based systems. These are some of the literature survey that I have taken for how the technology was developing, how the, for example, in 4G that we are using, the speed of the network is at 3 to 7 gigahertz. Now we are using a 5 to 5 to 6 gigahertz. That is an increase of the network connectivity. From 2022 and 2022 onwards, we are taking the literature survey of different papers, how the network connectivity, how the images are, or how the encryption data is saving in the cloud-based system to share the informations. So here, these are all the literature surveys that I have taken, sir. So from this literature survey, we have identified what are the possibility problems that we can easily identify. Interface from the internet, growing concept in the cloud computing, and emerging trend in the file encryption. The encryption system is already available from 2000 onwards, but at the same time that we are having not enough time of sharing the information through the Gmails or in network connectivity. And at the time we are using a 1G, 2G or 3G network connectivity and saving the information large kind of files. So we can't be able to make it more efficient at the time. So by the literature survey, we can identify what are all the problems and what are all the future works they have done. What are all the things that they have done and they have what are all the future work they are going to do, and we can make it as a more efficient for us to do that project, and what are all the problems they are facing, and we are making it more efficient to share the information from one place to another place. And this is the system. In the existing system, the cloud-based security system, data encryption primarily relies on conventional cryptographic techniques like AES or RSA. The AES and RSA are techniques are used in the elder days. The elder days that they are using AES and RSA to effect to save the information in any kind of images by sharing from one place to another place to hide the information very securely by using the password protections. This method encrypt the data with a mathematical algorithm. Some of the mathematical algorithms and some of the information and some of the data that we have been saved, and some of the algorithms also that we are using in this by using some of the network keys or password keys or any kind of images or any kind of decryption tools. Here I am doing the project with the help of a encryption tool. Means in the opposite side also they need a decryption tool by by decrypting the images from one images to another images, or splitting the information from an image. So proposed methodology in our proposed, we are aimed to how the large amount of files that has been saved and a large amount of file how we are sharing by using the tools. Some of the different kinds of tools are already available in the market and already available in the online stuff. So we have make a more secured tools to encrypt the data, and using the password protection, different kinds of password protection also we are working on that. But we are using only a number password systems or a patterned password systems and some kind of encryption tools that we are using to make it more efficient. These are the architecture diagram of the first is a user interface and authentication and authorization, file management, and noise image generation. Noise image generation is nothing but if we are adding some kind of images in from one some kind of files in one images means, then we can make the images as a noisy, so we can't able to identify the information inside those images. If any kind of hackers or any kind of theft that they are hacking that images means, they can see only the noisy images, but that she can't able to identify whether some of the information is placed inside or not. So it is very much advantageous for us to make it more efficient. File encryption with the noise images, cloud integration, decryption process, and monitoring and logging. For example, if I am sending one kind of information from one kind of images from one place to another place with the help of a tool encryption to make the file inside the encryption tool means, then we are sharing that information from one place to another place. They are also having the same encryption tool, decryption tool. In the same decryption tool, they are having some kind of password protection that I am sharing it in a mail or a WhatsApp or any kind of things to decrypt that images, and they can easily identify the information whatever it is saving. Here that we are using a cloud-based process. Why we are using a cloud-based process means, because we are sharing the large amount of files or large amount of data means that we require a cloud computing. So here we are using a cloud-based AWS or some of the SQLs or database that we have saved the information in the online to share the information. The first model is a data acquisition and a noise generation. First we have done is taking one kind of images. From the images we are adding some kind of another files, some kind of files that we are hiding in that images. That is called as an encryption that we have done is here, and make the images as a noisy manner and make the encryption as a noisy manner. After that noisy manner, we have encrypted the data or any kind of files with the attaching the two images or any kind of two files that are attached in the images, and we are sending that images to the another person. They have some kind of and we have put some kind of protection in it, some kind of passwords or some kind of keys or some kind of answerable questions like that. We are putting some kind of protection in it, and we are sharing it into another place, or from file to source to destination, and the destination have the decryption tool to decrypt the file with the help of the decryption tool, and decrypt with the help and if I am sharing that password protection, some kind of number password or a patent password or any kind of keys or any kind of question answers like that means, I am sharing that information to the particular person. Inside that any kind of hackers is hacking means they can't able to get that informations. Here in this we are first we are this is the tool that we have created. In this tool that we are giving the username and the password to submit entering into it. After that after that we are adding, so first we have to add one images. After that adding the images, we have chosen some kind of images, another images or another file to make it more encrypted. After that we have download that file, and downloaded file we have been sending from one place to another place. In the same manner on the opposite side also downloading that images and making the same tool to decrypt the images. Once the image is encrypted means it will be showing like this in this picture. In this picture like this only the images will be shown. If the hacker is hacking means he can't be able to identify what kind of images it was and what are the information that is hiding in it. They can't be able to understand and they can't be able to retrieve it also, because we are making the tool with the we are making the encryption tool and the decryption tool with the protection of the security. And the same process once the process is done means another the opposite decryption process is also the same thing. Whoever is in the opposite means they have downloaded the photos or downloaded the images or downloaded the file means, after that they have downloaded the file, they have opened the file in the decryption software, and the software to decrypt the images that have separated the images with the files that have been encrypted. As the result, what are the main aim of our project is already the encryption and the cryptography is already there. So in this we are using a noisy images and a cloud-based system. Noisy images is nothing but if I am sharing some kind of images means in sometimes it will be showing easy manner to hackers to hide it, open the images and all. So if we are making a noisy images means they can't be able to see the images, whatever images it was. So they can't be able to decrypt it. So this is the main aim of our project, and here we are using a cloud-based security system. So share the information with a large amount of files, and it is moreover now the technology was developed, and we are using a 5G technology, so we can easily download the files or 500 GB or 100 GB or 500 GB or any 1 TB of images, 1 TB of files that can be easily downloaded with the help of a 5G network. So that's all, sir. Thank you.
Hello.
Yes, sir.
So can you hear me?
Yes, sir.
Yeah, your topic is very good because it's very interesting. Instead of using only like, but what I found something. Can you hear me? Is it?
Yeah,
Am I
yes, sir.
audible,
Yes, sir.
please? Yeah.
Yes,
Okay.
sir.
So, but I found like little bit. It could be advanced because you have only using for encryption, decryption. You are in and putting some noise into the images, and then you wanted to encrypt using the through that noise. Am I correct?
Yeah, yes, sir.
Okay, so but I am really little bit worried. Why not? There are so many encryption techniques are available nowadays. Even you can use advanced encryption techniques, as well as there is a adaptive hybrid encryption technique is also available. But because putting noise only because I can denoise the images, even if you are using high level of noising noise into the image. So there are several methods that I can use to denoise the image. So how it is feasible? That's I am little bit worried about it.
Okay, sir. Okay, sir. We are working on that, sir. We are working on that. First process is I am doing the project to make the my
Okay.
images noisy is not a normal one, not a it's a starting process only, sir. It's a starting process with the
Okay.
help of the cloud that we are making, sir. So only we are using the noise process as a base one. In the future, that we
Okay,
will
I
making more.
suggest it is I look at this approach also because if you are using noise, it's okay, but you can try to include some advanced encryption techniques. Advanced encryption methods can encrypt the images because if someone will denoise images also, then also they will not be able to read it out because it's a they require the key to decrypt the image, and that key is very like 128 bits key it requires, or 256 bit key it is required. So I suggest you can look for that purpose, that also it will make your paper or your project much advanced as compared to the current one. Okay, sir.
Okay, sir. Okay, sir. Okay, sir.
Okay, thank you, sir. Thank you for your wonderful presentation. Yeah,
Thank you, sir. Thank you, sir.
welcome.
Okay, thank you. Thank you, sir. And thank you so much, our session chairs, Dr. Hari Mohan Rai sir and Nita ma'am. Thank you for joining us and giving us a valuable time.
Okay, most welcome, and thank you for inviting us. And it is a great privilege to be the part of this conference, and hopefully we'll collaborate in future also. So best wishes from my side. Good luck.
Yes, yes, sir. Thank you so much, sir.
Welcome.
Okay, sir.